Welcome to Rges Pre-Algebra. This is Lesson 20A, and we will be covering sections 4.15, which is a review section, and 4.16, which is word problems. So go ahead and get out your book because I will be referring to it in this section. Put the tape on pause, get your book, and come back to page 139. So covering 4.15, I'm going to have you do most of these by yourself, but I will do a few example problems for you to remind you of what you're doing here. So let's look at 28 together. And even though that's a sign, go ahead and do it when you get to it, but this is just to quicken your understanding. I have the expression y squared minus x squared, and I want to evaluate that if x equals 0.1 and y equals 3. So I would go ahead and plug those in, and I would get 3 squared minus 0.1 squared. So there's nothing difficult about 3 squared. That's just 3 times 3, or 9. But there might be something difficult for you about 0.1 squared. And this is really just a review of your decimals. 0.1 times 0.1 is 1 times 1 is 1. But now I need 2 decimal places. So I would have to go over 2 because there's 1 there and 1 there. You add them up, and you're going to get 2. And so this would be minus 0.01. And then, of course, your answer would be 8.99. So that's just a review on how it works when we're multiplying decimals. This is the part that concerns me here. All right, the next one I'd like to remind you would be maybe something like 38. When we have these multiplication and division problems, this one being the division problem, and we have multiplication of variables with powers, we're going to break this into its parts. First, I'm going to deal with the number part. 25 divided by 5 is 5, and I would write that in the numerator because my larger number is in the numerator, the 25. Then I'll look at my m's. I have 1 m in the numerator and 2 m's in the denominator. If I cancel, I would get 1 m in the denominator, and then I would look at my n's, and that is n cubed. So I have 3 n's in the numerator, 1 in the denominator. Recall that you are either canceling them out, writing them out, like n times n times n in the numerator, and canceling, or you would be subtracting exponents. I have a 3 in the numerator. It's not written down, but the exponent that you're thinking in the denominator is a 1. And so 3 minus 1 is 2, and that would go to the numerator because the larger number of n's is in the numerator. And so that would be the answer there. And I think most of you are very comfortable with that, but we're going to just review that. Now, probably the most difficult in the next section would be number 44. This is an equation, solving an equation with fractions. Recall that we generally do not like to work with fractions, so if we have a simple way to eliminate them, we'll take it. Our simple way to eliminate this will be to go ahead and identify the least common denominator. That would be the first number that both 10 and 4 go into evenly, and 4 does not go into 10, but if I double 10 to 20, 4 does go into 20. And so I'm going to multiply that 20 by every single term. 3/4 x plus 20 times 7/10 x equals 20 times 29. Don't forget, both sides of the equation, every single term. Now when we do that, A 4 goes into 20 5 times. 5 times 3 is 15x, plus 10 goes into 20 2 times. 2 times 7 is 14x, and 20 times that would be, 58,580. Now, I believe that you can do the rest of that problem without any difficulty. I just wanted to remind you of how you're going to approach it. I don't think anything else here in 4.15 will give you any trouble. So let's move on to word problems in 4.16. Look on page 142 in the explanation up at top, and the word problem says, James is 4 years older than his sister Elizabeth. If the sum of their ages is 18, how old are James and Elizabeth? And oftentimes I just like to, we could either, just write variables to the left, or sometimes I like to write a little chart. I think I'll show you that way since it's a little different from what he's showing you. But I like to write it in English. We have Elizabeth and James. Okay. Elizabeth, we don't know what her value, how old she is, so I'll just call her X. She's X years old. James, this just helps me keep track of what I need to talk about. As far as the variables, I need to understand the components of the problem. It says James is 4 years older than Elizabeth. So if Elizabeth is X, what would James be? If he's 4 years older, how would I write that? I would write that as X plus 4. And the sum of their ages is 18. So now I want to take Elizabeth plus James, their values, and that will be 18. Well, Elizabeth is X. That stands for Elizabeth. And James is X plus 4. And altogether their sum, which would be addition, which is what I've indicated right here, is 18. Now we have an equation. So the first thing we want to worry about is identifying each of our variables and how we can write them all in terms of one variable. The second thing, at least for Algebra 1 right now, the second thing we want to do is write an equation. So this is step 1, this is step 2, and step 3 would be to solve it. If I have x plus 4, I would add the x's together, and that's going to give me 2x plus 4 equals 18. Then I would subtract the 4 to the other side to get that away from the x. Remember, my goal is to solve for x. You always do the addition or subtraction before you do the multiplication or division. So I've got 2x, subtract 18 minus 4 is 14. And now I want to do the opposite of multiplication, which is division. 14 divided by 2 is 7. Now, I haven't really answered the question yet. What I've done is solve it. So my fourth step would be to go back to the question and answer it. The question is, how old are James and Elizabeth? Well, Elizabeth, she's the one that stands for X above, so Elizabeth is 7 years old. And James is, go back up to your variables, Elizabeth plus 4. If Elizabeth's 7, then James is going to be 7 plus 4, or 11 years old. And that's how we do a word problem. I'm going to show you several others, going through them a little faster than that. The second example on page 142 says 5 times a certain number is 155. What is the number? Now here I don't need to really write a chart because I'm only talking about one number. So that one number is going to be X, right? So I don't really, since that's the only thing I'm really talking about, I'm just going to now read off the equation. So section 1 up above we don't really need. But how would I create an equation? Well, it says 5 times a certain number. The certain number is x, so 5 times x is I think of as an equal sign, 155. So essentially up above, this would be my section, my second step. My third step would be to solve it. I would solve this, so there's my equation. I would solve it by dividing both sides by 5 or dividing the other side by 5. Either way you want to look at it, because I want to get rid of the 5, and the opposite of multiply is divide. So 5 goes into 15 3 times, 5 goes into 5 1 time. So there's my solving the problem. And number 4, there's really nothing else to answer. I don't have to interpret. So this is kind of a truncated problem. I only needed to do steps 2 and 3. Let's look at the next example. The problem says the sum of twice a number and 11 is 45. What is the number? Now again, this is a truncated problem because I don't have more than one variable. Okay, so what I'm going to do is just go right on to step 2, write the equation, because all we're talking about is a single number. It says the sum is a plus sign. The sum is twice a number, so let's represent in the first section twice a number. The number is going to be x, so this would be 2 times x. And 11, so and would represent, I'm getting ready to talk about the second number, okay, in my sum. So, and 11 represents my equal sign, 45. Now let's look at my equation and make sure that makes sense to me. I'm going to read it in English. I said, the sum of twice a number and 11 equals or is 45. So pause if that doesn't make enough sense to you and make sure that you can think that through. Now the third step then would be to solve it. Recall that if I solve it, I have to deal with this before I deal with the 2 because I'm adding. So the opposite of addition is subtraction. So I would say 2x equals 45 minus 11. That would be 34. Now I still need to get rid of the 2. So I end up with x equals, the opposite of multiply is division, divide by 2, and you're going to get 17. So this is my answer, again, because it says 4 would be to interpret the answer, and there's no interpretation needed. I can stop there. Now to check yourself, of course, what you would do is you would take this answer, 17, and plug it back in to your original equation. 2 times 17 is going to be 34. 34 plus 11 is going to be 45. And so once you check it that way, you can see that it has a solution. Let's look at the next problem. I don't mean it has a solution, I meant it is the solution. All right, it says 6 less than 3 times a number is 51. Why don't you look at page 143 and pause, just read that question without reading any of their explanation, see if you can write the equation. Again, this is going to be truncated. We'll only need steps 2 and 3, but it says 6 less than 3 times a number is 51. So to write this equation, there are a few tricks here. Okay. The first trick is this stands for an equal sign. Okay. 3 times a number is my x. Okay. Now, 6 less than, it tends to represent a challenge for many students. If I have 6 less than another number, this is going to be the first number, and this is going to be the second number. 6 less. Okay? So let's start with my first number. 3 times a number. 3 times a number. 6 less than would be minus 6. That's the one you want to look at. Is means equal 51. And now we just need to solve it. I need to get rid of this first. So I'm going to have 3x equals, the opposite of subtraction is addition. So that would be 56. 6 plus 1, how about 57? I need to get rid of this next. X equals, the opposite of multiply is divide. And 3 goes into 5 one time with the remainder 2. 3 goes into 27 9 times. So the number would be 19. Okay, I want you to go ahead and do all the ones that I assigned there, and we'll review what we need to on Wednesday in class.